Children, same chapter 12, algebraic expressions. We already completed exercise 12.3. Now the next topic, using algebraic expression in formulas and rules. Now why we are studying algebraic expressions, that we will come to know from this part only. See, in maths we know the formulas and all. Formulas are forming based on the generalized rules only. Now this is an equilateral triangle. For what is the perimeter of this side of this equilateral triangle? If the length of the one side is, if it is a, then the second side is also a only, since it is equilateral triangle. So the perimeter, we will write that perimeter of this equilateral triangle, will write that a plus a plus a. Now instead of this, if we write that 3 into a, where a equal to length of one of the side, where a equal to length of the side. So instead of writing a plus a, we can write 3a, that is the formula, and this formula we can call it as a algebraic expression also, because the variables, constants and the operations, all the things are involved here. Now this is easy to remember and easy to calculate also. Now if it is a square, if you take the side of the length will be, let us take as a L only. So 4 times L only. Similarly, perimeter, if you calculate, we will write that L plus L plus L plus L. Instead of that, we can write 4L, where L equal to the length of one side. Okay, like that we can write the formulas. With the help of the formula, we can calculate this perimeter of this square very easily. Now we'll go for a rectangle. Let L be the length and B be the breadth. So what is its area? We can write area equal to L into B, or we can write LB. So we got that say, even in the case of the square also we can write it is equal to L square only. Like that we can form the formulas only. So with the formula we are able to find the respective perimeter or the area depending upon their formulas. So what is the way the algebraic expressions help here? If length of the side of the equilateral triangle A equal to 3, what we are told, A equal to 3, the length of the side of the equilateral triangle. Then the perimeter equal to 3 into 3a, we will write the formula first. 3 into 3 equal to 9 centimeter. Like that. If L equal to 4, then perimeter of the square equal to 4L equal to 4 into 4 equal to 16 centimeter. Similarly, L equal to 5, B equal to 2 for a rectangle. Then the area of the rectangle. First formula LB, then 5 into 2, if it is in 10 centimeter square, if it is in a centimeter, it will be 10 centimeter square. So with the help of the formula, we are able to find the perimeter and the area respectively, right? Now what here we are doing, algebraic expressions only, all this. If it is take 3a, if it is we are taking 4L, if we are taking LB, all these are algebraic expressions. All these are algebraic expressions. What we learned from here means algebraic expressions make the formula. Make formulas here. Okay. Formula, in which way it is helping us? Formula makers easy to find area of the geometrical area, perimeter of the geometrical figures. Okay. Now don't think that only we are able to find the formulas only. Sometimes identities we can use a plus b whole square, a square plus b square, like that. So like this we can use the algebraic expression. So mainly we are talking about formulas only. So algebraic expressions help us to derive or form the formulas. Next topic, rules for number patterns. The means how we are using algebraic expression in making the rules in the number patterns. If a natural number is denoted by n, then its successor is n plus 1. You have studied already in the 6th class successor, predecessor and all. The same rule only. If we are considering as a natural number is n, the next number we will get by adding 1 only. So we can write n plus 1. For example, n equal to 10. The next number you already know that it is 11 only. How we are getting that one? 10 plus 1 equal to 11. Next, n equal to 100 if you are taken, then how you can calculate the successor? So n plus 1 equal to 100 plus 1 equal to 101. That means we are replacing the values of n. How we are finding the values of the expression? The same way. This n is replaced with 10. N is replaced with 100. So some rules we found. What is the rule? If n is the natural number, then the successor is n plus 1. So we are calculating by using algebraic expression only. If a natural number is denoted by n, then the general form of an even number is 2n. Let us see how we are getting this one. We know that the even numbers are 2, 4, 6, 8, 10, etc. So for getting the first number, we are replacing n by 1 only. So 2 into 1, so it is equal to 2. 2 into 2, it is equal to 4. 2 into 3, 2 into 4, like that it will be continuing. So we want to know that the 100th number. If first number we want means n is replaced by 1. Second number we want means n is replaced by 2. N is replaced by 3. By this we get third number. Like that I want 50th number. 50th number, even number I want. 50th even number means what I should do? 2 into 50, it is equal to 100. Now 100th even number I want means 2 into 100 equal to 200. Like that we can calculate any number from this group. That is why this is a rule for even number. Which is the rule? 2n is the rule for even numbers. Now see, we have already seen the rule for even numbers. Now we are getting a number pattern 4, 7, 10, 13, like that. What is this means? We are taking the line segments of equal length and arranged into some shapes. Then here it is almost equal to a square only. So we can identify how many matchsticks or anything line segment we have used here for making the square means 4 only. 1, 2, 3, 4. For the second pattern, that means one more square we joined together. So this became a common there. So we need only 7 line segments. Similarly here, for getting 3 squares, 10 line segments, like that 13 we have got here. So we are getting a pattern of 4, 7, 10, 13, etc. Now we should identify a rule for this one. So first number is 4. So for getting 4, we can let us go with the natural number n equal to 1 only. So let us try with this pattern as 3n plus 1. So this time n is the first term. So we will get 3 into 1 plus 1, we are getting 4. The same pattern, because the 4 we are writing as a 3 plus 1, right? So 3n plus 1. Now here it is 7. 7 means 6 plus 1 only. So the second term means 3 into 2 plus 1, you are getting 7. Now 10 we want, that is the third square. 3 squares are there, so I am putting 3 here. 3 into 3, 9 plus 1 equal to 10. So we are getting a rule like this, and by using this rule we can identify how many line segments we need for making this such patterns. Now another pattern here, they have formed a U shape here. So how many line segments they have used? 3. 1, 2, 3. So I'll write here 3. Again 2 U's used. So 1, 2, 3 on the upper part, and the bottom line we will get 2, so 5 we are getting. Similarly, it is 7 and here 9, and this process is continued. Now we should identify a formula for this one, a rule for this one. So 3 we are splitting as 2 plus 1. So we will try the pattern 2n plus 1. Right? So 2n plus 1, n equal to 1, where n is the natural number. So 2 into 1 plus 1 equal to 3. So we are trying which pattern? 2n plus 1, and the first number is 1, n is replaced by 1. Now the second case, 2 we are replacing with n. So 2 into 2, 4 plus 1, it is equal to 5. 2 into 3 plus 1, 7. 2 into 4 plus 1 equal to 9. Right? So we are satisfied with the first 4 numbers whichever we want to u, and the rule for u alphabet we can take it as a 2n plus 1. That means these many line segments we have used for making this one in each section. Okay. Similarly, 2 more patterns are explained in your textbook, that is the letter P and the letter H. In letter P also they have used 5, then the 2 P's means 9 they have used. So the pattern you must study, it is 4n plus 1. The pattern is 4n plus 1. Similarly, H they have used 5, then it is 8 only. So usually we will go for 4n plus 1, 3n plus 1 only. Here the pattern little bit changes. What is the pattern? 3n plus 2. So like that each situation pattern will change. So while writing or trial and error method only we can find out the patterns. This is for understanding 2 more set they have explained. Some more dot patterns also given in your textbooks, that is 1 dot here, 4 dots, 9 dots. What are the how many dots? 1, 4, 9, then if you go for this one 16. Like this patterns if you go continue means it is an example for square numbers. So we can write the pattern here as n square. N equal to 1, 1 square. N equal to 2, 2 square, it is 4. N equal to 3, then 9 we will get. N equal to 4 means 4 square, 16. So the pattern for square number equal to n square. Similarly, this is multiplication table they have explained, 3, 6, 9, 12. That means 3 into 1, 3 into 2, 3 into 3, 3 into 4. So the general form is 3n. General form is 3n. Similarly, 4 table means 4 into 1, 4 into 2, 4 into 3, 4 into 16. So the general formula is 4n. Like that, any multiplication table also we can write the rule. Number of diagonals drawn from one vertex of a polygon of n side. Usually we know that diagonals of a square only will take means how many we can draw opposite vertices to be joined. That means we can draw all the diagonals present in that polygon. Now we are taking that only from one vertex. So how many diagonals we are having here? So first I'll check the number of sides only. What is the number of sides for this polygon? Number of sides is equal to 4. And how many diagonals we have drawn here? Diagonals from one vertex. Remember this word, one vertex. We are not drawing the diagonals for all the diagonals. So diagonals from one vertex. How many? It is only 1. Now here how many diagonals, how many sides are here? 1, 2, 3, 4, 5. And from one vertex how many we are doing? 2. Okay, now how many sides are here? 6. 1, 2, 3, 4, 5, 6. How many diagonals are from one vertex? 3 only. Now what is the here means number of sides then less than 3. If it is n is 4 minus 3 will be 1. So we are getting a general formula or a pattern for this one. N minus 3 diagonals can be drawn from one vertex to of a polygon of n sides. That means here 7 sides are there, means how many diagonals we can draw? 4 sides. We are not telling here that how many diagonals are possible. What we are teaching here? Number of diagonals. What is the concept here? Number of diagonals drawn from one vertex of a polygon of n sides, right? That means what? From one vertex we are taking, if A selected vertex means A only we are using. We are not drawing any diagonals from B, C, D, E. Here also you see A only we have chosen. We are not drawing B, C, D, E, F also. We are not touching only for drawing the diagonals. Only one diagonal we have taken. Suppose we have taken a diagonal quadrilateral 4 sides figure only we are taking. If I have marked here A, B, C, D. Now based on this question, if I have chosen B, I should draw only BD. I cannot touch C and as well as A. So how many diagonals are possible here? Only from one vertex we can draw n minus 3 diagonals. Since the number of sides is 4, diagonals will be 4 minus 3 equal to 1. Now see similarly here, how many sides are there? 5. 5 is n. n equal to 5. What is the formula says? n minus 3. So 5 minus 3, it is equal to 2. Now what is the number of sides? 6. What is the number of diagonals from one vertex? 6 minus 3 equal to 3. So now the side is n equal to 10. So the number of diagonals drawn from one vertex, what is the formula? N minus 3, that means 10 minus 3 equal to 7. Now n equal to 15. Number of sides is 15. Then number of diagonals, what is the formula? N minus 3 means 15 minus 3 equal to 12. So the formula is for which one? Number of diagonals drawn from one vertex to any number of sides, right? So the formula is n minus 3. With this we are winding up today's class. Thank you.